Hi, okay, so today we want to talk about our significant figures, or what they're normally called is sig figs. And these are just numbers that tell us how precise, how accurate your measurements were. Okay, and so when you're doing an experiment or you're writing out some sort of formula or an equation and you're writing down the answer, you're telling the reader how much precision did you use when you were measuring these numbers. So an example would be if you say that something is about 1,000 years old or something is 972.8 years old. Okay, obviously the 1,000-year-old number, you may be estimating that, but 972.8, you're being a lot more precise with that. Okay, and so you want to let the reader know how much precision did you use. Okay, and they're relatively simple to do. If we just follow, there's maybe 4 or 5 or 6 rules you have to follow, and if you can kind of keep in track and realize that most of it involves zeros, they're reasonably simple. So let's go through these basic rules that we have, especially starting with the zeros. Okay, so very first rule we always have to know is it's the leading zeros. Leading zeros are never significant, okay? Never, ever, ever, ever. Okay, so here we go. Let's give an example. I have 0.005. Okay, these zeros in front, in other words, the leading zeros, they do not count as being significant. Okay, we don't look upon them as being measured precisely. So if I'm going to ask someone how many sig figs are in this number, they're going to write down the answer as 1, because these leading zeros don't count as being precise. They're not significant. All right. The second rule we need to talk about are trailing zeros, and there's about 2 or 3 different rules to look at with that. The first rule with trailing zeros is, and I'll give you a number of, say, 5,000. I have 5,000. There's no decimal here. Okay, if I have trailing zeros and there's no decimal point, the zeros are not significant. Okay, so if I'm going to be writing down how many significant figures are there, I'm going to say there is 1 significant figure. But let's say I add a decimal point to that. Right here, I have a decimal point. If a decimal point comes into play, trailing zeros are always significant. So in this case, this 5,000, we put a decimal point there. We're telling the reader that we accurately and precisely measured something to exactly 5,000. Okay, so in this case, 4 significant figures. If I change this up a little bit and I write 5,000.00, okay, because there's a decimal point, all of the zeros are significant. 1, 2, 3, 4, 5 zeros plus the 5 gives us 6 sig figs. Okay. The third rule with zeros that you have to think about are captured zeros. Okay, so if I have a number like 505, this has 3 significant figures. And that's because the 0 in the middle is always considered significant. Okay? Now if I have something like 5050, well, that 0 at the end is not significant. Okay? Because there's no decimal point. But the one captured in there is always considered to be significant. So those are the 3 essential zero rules that you have to follow with significant figures. Now, what you're looking for is, when we start doing things like addition and subtraction, you're always looking for which of your numbers was the least significant. In other words, which was the least precise, and then you're going to give that to your final answer. So there's a few rules involving that, so let's talk about those next. And so we're going to go through 2 of them, the 2 basic math functions that we need to use. I'm going to lump multiplication and division together because they have the same rules, and I'm going to lump subtraction and addition together because they have the same rules. So let's start with the easy one. We'll multiply and divide. Okay, so let's say I have a number like 4.0 times 2.00, we'll just say 2.00. Okay, now in this case, the answer is obvious, right? This is a fairly simple math problem. I'm just doing 2 times 4. So I know that it's going to be 8, but I need to know, well, how many numbers do I put past the 8 there? Well, I have 2 significant figures here, and I have 3 significant figures here. with multiplication and division, all we do is we do the basic math step, and then we look to find out which of the numbers that we're multiplying or dividing has the least number of significant figures. In this case, because this one had 2, as compared to this one having 3, we're going to go with our final answer has to have 2 significant figures. So 8.0. All right, same thing with division. I can do the same thing. I can say 6.00, and we're going to divide that by 2.0000. Okay, it's an easy enough math equation. We know that 6 divided by 2 is equal to 3. So now I just have to figure out how many significant figures am I going to have in my answer. And since this one has got 3, because I have a decimal point, so those trailing zeros count, and this one has 5, I'm going to go with whichever one has the least, and I'm going to have to put this in as 3.00. 3 significant figures. All right. Addition and subtraction, slightly different rule. Addition and subtraction are only interested in what's happening to the right of the decimal point. So let's say I'm going to add something simple, like say 1.50, and I'm going to add say 15.1. Okay, and this is an addition problem. All right, so when we go through and we actually do the math on this, right, I'm going to do 16.60. But what I'm looking for with addition and subtraction is what I'm going to be focusing on the numbers to the right of the decimal. So in this case, there's 2 significant figures. In this case, there's 1 significant figure to the right of the decimal. So I'm going to make sure that my answer only has 1 significant figure to the right of the decimal. So the correct answer to this with sig figs is 16.6. Okay? And that's, even though these numbers here, this one has 3 significant figures, this has 3 significant figures, but what I'm not really interested in the numbers to the left. I'm only interested in the numbers to the right of the decimal. Let me give you another example here. So let's say I have 10,000.0, and I'm going to add 5.006. Okay. And so in this case, we can go ahead and do the basic addition on this. And I know I have 10,005.006. But what I have to look at is I'm not interested in these significant figures to the left. If I was just looking at total sig figs, this one has 4, and this one has 1, 2, 3, 4, 5, 6. So if it was in a multiplication problem, I would just say, well, I'm just going to go with 4 significant figures. But since it's addition, I'm looking it to the right. So right here, 1 sig fig. Right here, 3 sig figs to the right. So my answer can only have 1 significant figure to the right. So this is 10,005.0 is your answer on that. And it works exactly the same way with subtraction. Okay, so now I want to talk about a couple of kind of tricks to look at with significant figures. Okay, so the first one has to do with conversions. Conversions can be kind of an issue with students sometimes. It's kind of tricky to tell exactly what the significant figures are when you do that. So let me give you an example here. We'll do something sort of simple. I'm going to put up sort of a basic problem you might run into. So let's say that I have something, say a runner. A runner is going 10 kilometers per hour. Okay, so I have this number here, and there's 3 significant figures in it, and I want to convert that and see, you know, what is his speed, or velocity we'll say, since in meters per second, okay? And so I can do some pretty quick math on that. We can convert kilometers to meters, right? We can say 1 kilometer is 1,000 meters. Okay, so I guess we're rid of my kilometers. And we can say that 1 hour is the equivalent of 3,600 seconds. Okay, and so this gets rid of my kilometers, and I'm left with my units of meters per second. So I know that I basically just have to multiply across 10 times 1,000 would be 10,000. And I'm just going to do the math without putting any decimals or anything in there. And I know that it's going to have 3,600 seconds. So I have meters and I have seconds, and when I do the math on it, it's going to come out to 2.77777 repeating. Okay, now how many sig figs do I have in there? Well, there's a couple of things to look at. So right here I have 10.0. Okay, so this is 3 significant figures here, right? But here I got 4. Well, I have 1 significant figure here, but maybe it's 1,000.0 is 1 kilometer, and then it's 1 divided by 3,600.0 seconds. Or maybe it's just 1 divided by 2 significant figures and 1 divided by 1 significant figure. So maybe I'm just going to go with 1 and 1. So the trick with conversions, when you have a conversion, you should assume that the significant figures in that case are infinite. So if I say there's 5,280 feet in 1 mile, we're not going to say, okay, because it's 1 mile, that's 1 sig fig. We're going to say that those conversions are infinite. We don't really count them when we're looking at significant figures. So just kind of pretend they aren't even there and look at what you have here. And so my answer to this is that if I'm going to convert 10.0 kilometers per hour to meters per second, it's actually 2.78, because I need 3 sig figs, so I'm going to round down, or round up a little bit, I guess in this case, meters per second. So 3 significant figures, because I had 3 significant figures there, and I am going to ignore the conversions or assume conversions are infinite. All right. Okay, and there's the last one I want to talk about is the use of scientific notation whenever you're doing significant figures. So scientific notation can really save us in a lot of incidences. The cool thing about scientific notation is it tells the reader exactly how many sig figs you're using. Okay, so I'm going to give you an example here. Let's say I have a number like 6.022 times 10 to the 23rd. Okay, so I have Avogadro's number here. When you're looking at this number, this is telling the reader that, yeah, okay, I have 23 zeros out there, but it's significant for the first 4 digits only. Okay, that's what this is telling us, is that we have accurately measured it to the 1,000th place. Okay, and so whenever a lot of times, if you're in doubt about how to write down your significant figures, use scientific notation. Okay, so let me give you a quick example here of something that would come up like that. I'll take a number, some numbers I kind of pieced together here. So we're going to take 43.678, and I'm going to multiply that by 64.1. Okay? Now, when I go out there and I do the math on this, it turns out that it equals 2,799.7578. Okay, and obviously now we have to go through and figure out, the significant figure aspect of it. So in this case, I got 1, 2, 3, 4, 5, and in this case, I got 3. So I know that since this is multiplication, that my final answer has to have 3 significant figures. So I got a couple of things I can think about here. Well, I'm going to have to round up in this case, but if I put this in as 2800, well, that only has 2 significant figures. Okay, it has to have 3. I can't put a decimal right here because that gives it 4 significant figures. So this is an instance where I want to put it into scientific notation, and the way I want to do this is I'm just going to write down that this is 2008.0 times 10 to the 3rd. Okay, 1, 2, 3. So this gives me a number of 2,800, but it's precisely measured to the 3rd spot there. Okay, so whenever you have a number like this, anytime you're in doubt, go with scientific notation. A lot of times it'll solve the issue with you for significant figures. Okay, and that should get you through the basics of sig figs. There are some things that get a little bit more complicated, logarithms and things like that. We may talk about that going forward, but most of the time, if you can just follow the rules for zeros, the rules for multiplying and dividing, the rules for addition and subtraction, and then just kind of watch out for a couple of simple things like this. With scientific notation, you should be able to get through it relatively easily.